Restriction is called triangle inequality. And here's basically what it is saying. If you have these, again, three sides of your triangle, the triangle inequality states that any three sides, any two sides in a triangle must be greater than the third side. Okay, so this is the triangle inequality relationship. Okay. It's abbreviated with just the triangle symbol and then an inequality symbol, or not equal to symbol. And what this basically is saying is the following. In this triangle, AB plus BC has to be greater than AC. Okay, so looking at this, we know that AB plus BC is greater than AC. Now, in addition to that, AB plus AC has to be greater than BC, and BC plus AC has to be greater than AB. All of those relationships have to hold true. Now, it should make sense for these to hold true, because let's say we took side AC, and we took it away from this figure, and let's say we made AC this length right here. If we were to take this and identify a length where it maybe doesn't fit this condition, if I place my compass and I draw my arcs, here all points along this circle will be a distance of BC away from point C. So B has to fall somewhere on that circle. At the same time, I'm going to extend this even further. All right, so I'm not going to extend it quite that far, but let's say here is my point A. If I know that AB is going to lie somewhere, I also know that B has to lie somewhere on this point. If the relationship is not held true, if this triangle inequality does not exist, then that would mean that can AB and BC ever create a triangle here? No. Here's a case where AC is larger than the sum of the other two sides. Okay? So the only way that you can actually have a triangle enclose a space is if the sum of the two smaller sides, or any two sides, is greater than the third side. Okay, so if I had a case where, let's say this was 10, and this side was 7, and this side was 3, would these sides meet right there? Would they meet off of the base? If this length was 7 and this length was 3, where would those two sides actually meet? They'd meet right here, right? They'd have a length of 7 and a length of 3. Would those actually form a triangle? No. All they'd form is a straight line, right? Okay, but once we make one of them slightly larger, so if we made it 7.1 or 7.001 even, they would sit off of that line or off of that base and create a triangle. Okay, so when you find restrictions, there's a couple ways that these are going to apply. Okay, one way is it'll ask you, can these be three sides of a triangle? Okay, so if I gave you sides, okay, can these three be lengths of the sides of a triangle? Yeah, you take the two smaller sides, add them together. Are those greater than the third side? If yes, then they can form a triangle. Okay, what if you take your two sides and they're exactly equal to the longest side? Now if they're equal, it'll just be a straight line. So it cannot form a triangle. And then the final case, if you take your two sides and they are smaller than the third side, once again, they're not even going to enclose a space, so they cannot form a triangle. Okay. Does that make sense how you could test those to see? So that's kind of the straightforward aspect of these. The more challenging aspect that a number of students do tend to miss is finding restrictions on third sides. Okay, so if I told you that a triangle has sides of 10 and 7, what are the restrictions on the third side? Okay. When you're looking at this, you can find the third side has to fall between two values. And the way that you find these values is you simply assume that the unknown is the largest side. If we assume that the unknown is the largest side, what's the most it can be before it stops becoming a triangle? If the two smaller sides are 10 and 7, at the point where those meet, 10 and 7 on the line, it stops becoming a triangle. So we know that this third side can't be 17 or anything higher than that, because then it won't even form a triangle. So it has to be less than 17. And then the restriction on the other end is if this unknown is not the longest side, then which side would be the longest? 10. So the unknown plus 7 add together, and at the point where those two add together and give you 10, it stops being a triangle. Okay? The unknown has to be slightly more than that. So what number would give you that critical point? 3. And so here are the restrictions to your third side. It's a really easy calculation because what did we do to come up with 3? We subtracted the given values, and what did we do to come up with the upper limit restriction? We added them. And that's all you have to do on these. Again, students tend to miss this question, even though it seems like a pretty simple thing. So make sure if you're not understanding this relationship, ask.